Hello friend, in this video I will discuss about all Maxwell equations of electromagnetic wave with proof, such like derivation of Ampere's law, Gauss law of magnetism and Gauss law of electrostatics, and finally Faraday's law of electromagnetic induction. Electrodynamics before Maxwell. So integral form of electrostatics and magnetism. So first law is Gauss law, which tells about total integration of electric field with area vector equals to 1 upon epsilon naught volume integration of rho dt. And in case of magnetism, total magnetic field with area vector is 0 for closed surface. And third one is Faraday's law of electromagnetic induction, which tells about electromotive force, which is equal to the negative rate change of magnetic flux. That means E equal to minus d phi b by dt. In integral form, it is represented as closed integration of electric field with length vector of the wire in which current is flowing, which is equal to the magnetic flux change with respect to time. That means minus d phi b upon dt. And fourth one is Ampere's circuitous law for current carrying wire. Total magnetic field with respect to length vector equals to mu naught into I enclosed, means total current. And Lorentz force is given by F equal to QE, sum of electrostatic force QE plus Lorentz force Q into V cross B. So first of all, let's discuss about Gauss law, which tells about the total flux enclosed by a closed charge Q equals to Q upon epsilon naught. That means according to Gauss law of electrostatics, closed integration of electric field with area vector equals to Q upon epsilon naught, which gives total flux enclosed by the closed surface, which is called Gaussian surface. Talk about the proof of Gauss law. So suppose a positive charge which are enclosed in the surface S. So let us consider an small element ds from at which electric field is E. So if we calculate total electric field, which is E equal to K upon R square into Q. And if we talk about electric flux, that means phi, which is equal to total electric flux. Phi equals to total integration of electric field with respect to area vector. That means close integration of E dot ds. If you apply here the definition of dot product, which is equal to E ds cos theta, where theta is 0, that means electric field vector and area vector in same direction, that means angle is 0. So it will become E ds cos theta. If you put the value of E from the above equation, that means kq upon r square r cap, which tells about the direction of electric field. And k is constant, which is equal to 1 upon 4 pi epsilon naught, and epsilon naught is permittivity of free space. If you take out constant term, that means kq upon r square, then total integration will be ds for closed surface, which is equal to 4 pi r square. If you cancelling 4 pi and r square, then we will get q upon epsilon naught. So it gives the total electric flux enclosed by a charge q, which is equal to the surface closed integration of electric field with area vector ds equal to q upon epsilon naught. Gauss law for magnetism is very simple. That means total magnetic flux for a closed surface is 0. That means total in electric field lines for a closed surface equals to total out electric magnetic field. That means total magnetic flux for a closed surface will always 0. So in integral form we can say B dot ds. Here B is magnetic field vector and ds is area vector. So B dot ds close integration with respect to surface of magnetic field is always 0, and in differential form del dot b equal to 0. The del is a differential operator, which is equal to del del x I cap, del del y j cap, and del del z k cap. Now coming to the Faraday's law of electromagnetic induction, which tells about the induced EMF. That means if we change magnetic flux related to a coil by moving a magnet away or close to the coil, then there is change in magnetic flux related to the coil, which is equal to the electromotive force, that means equal to minus d phi by dt. And second law of electromagnetic induction states that magnitude of electromotive force induced EMF in a circuit is directly proportional to the rate change of magnetic flux through the circuit. And the first law is also called Lenz law, which tells about negative sign of magnetic flux. That means it opposes the cause from which it produced. Differential form of Faraday's law is del cross equal to minus del B by del T, and integral form is E dot del equal to minus d phi by dt. That means phi is magnetic flux through any surface with boundary curve C, which is called Faraday's law of electromagnetic induction. Faraday's law of electromagnetic induction. Whenever there is change in magnetic flux related to the coil, an induced EMF is produced in the coil, which is equal to the negative rate change of magnetic flux. That means equal to minus del phi by del t. If there is n number of turns in the coil, then it equal to minus n del phi by del t, which is equal to del t of n phi with negative sign. And induced current in the circuit equal to I equal to E upon R, means n upon R del phi by del t. And induced charge in the circuit equal to Q equal to IT simply, so it will equal to n upon R del phi by del t into del t, which is equal to n upon R into del phi. The third one is Ampere's circuital law. When there is current carrying wire in which current is I, then a magnetic field is created around the wire, which is equal to del B dot dl equal to mu naught into I, means total magnetic field produced with respect to wire equals to mu naught into I, where mu is permittivity of free space for magnetism, and differential from del cross B equal to mu naught into J, where J is current density, I equal to electric current, B magnetic field, and mu naught is permeability of free space. If you want to understand the direction of a magnetic field, then we have a right hand thumb rule. According to this rule, thumb points in the direction of the electric current and fingers curls around the circuit current, indicating the direction of magnetic field. If we suppose we have a current carrying wire in such that if thumb indicate the direction of current, then all the fingers wrapped around it indicates the direction of magnetic field. Derivation or proof of Ampere's circuital law. So suppose a current carrying wire with current I and magnetic field at point P is created, which is equal to B, and total magnetic flux is given by B dot dl. So from Biot-Savart law, the magnetic field due to long straight wire is given by B equal to mu naught ideal sin theta. Yes, ideal and sin theta angle between is 90, then sin 90 equal to 0. So B equal to mu naught I upon 2 pi r. Since B and dl are in same direction, so B dl equal to B dl cos 0, which is equal to B dl, because cos 0 is 1. So total magnetic flux with respect to dl equal to mu naught I upon 2 pi r, and the integration of dl equals to 2 pi r, because for closed loop total circumference is 2 pi r. So total magnetic flux phi b equal to closed integration of b with respect to dl equal to mu naught into I. Now fourth equation is modified Ampere Maxwell equation, which is equal to B dot dl equal to mu naught I, and additional term is epsilon naught d dt of surface integration of E dot dA. Here n is unit vector, tells the direction of electric field. So an electric current or change in electric flux through a surface produces circulating magnetic field around any boundary path. If we consider a current carrying wire in which current is I, then there is a magnetic field around it given by Ampere Maxwell equations, modified Ampere Maxwell equations. Modified Ampere's law is also called Ampere Maxwell law, in which a concept of displacement current is given by James Clark Maxwell, and the modified equation of Ampere becomes closed integration of magnetic field with dl That means total magnetic field is equal to mu naught into I enclosed plus additional term is mu naught plus I displacement. Here id is displacement current and I enclosed is basically conduction current, and it is also written as closed integration of b dot dl equal to mu naught I enclosed plus mu naught epsilon naught d phi e upon dt. Here id is displacement current which is equal to epsilon naught d phi e by dt, given and explained by James Clerk Maxwell and modified the Ampere circuital law. So the final equation is called Ampere Maxwell law. So this is all about in this video. Thanks for watching. Thank you so much.